In this video, we are going to be going over how to solve two-step inequalities. I have a few examples for us to go through, so let's go ahead and get started. All right, solving inequalities is very much like solving equations. The only new rule that we need to remember here is that when we are dividing or multiplying by a negative number, we need to flip around that inequality symbol. Otherwise, it's exactly the same. So let's go ahead and get started with this first problem. We've got 3x minus 5 is greater than or equal to 16. If you need a review on these inequality symbols and how to read them, I'll put a link right here for my video on solving one-step inequalities. And at the end of that video, I go over a little review of how to read these symbols. So let's go ahead and undo. Our rules are still the same. We want to undo any operations that are happening with our variable over here on the left-hand side of our inequality by using backwards order of operations, backwards PEMDAS. So I want to undo any addition or subtraction first. So I'm going to undo the subtraction of 5 by adding 5. So as you can see, our steps are pretty much the same as if we were doing this if it was an equation. So 16 plus 5, that gives me 21. We're just going to drop down that inequality. Instead of an equal sign, we're now using greater than or equal to. And then we're going to drop down that 3x. And then our next step is to divide by 3. Divide by 3, that's going to cancel that out. And then x is going to be greater than or equal to 7. Now we can always check our work just like we can with equations. We can check our work with inequalities. The difference is with inequalities, we now have a range of numbers that x could be. So x could be 7. But it could also be greater than 7. So it could be 8, 9, it could even be decimals and fractions, 7.5, 8.5, right? Any of those things. So I'm just going to pick a number, substitute it into my original inequality, and check my solution that way. So I could check the equal portion. So I could say that x is equal to 7 and plug that in, and I would probably get 16 over here on the left-hand side, but I really want to check that greater than portion of this symbol. So I'm going to go ahead and pick a number that is greater than 7. So I'm going to pick 8. I'm just make it easy for myself. So we've got 3 times 8 minus 5 is greater than or equal to 16. 3 times 8, now we're using order of operations to solve this left-hand side. So 3 times 8 is 24, minus 5 is greater than or equal to 16. 24 minus 5 gives me 19, and that is greater than or equal to 16. So I know that I'm good there with my solution. Let's go on to problem 2. We've got negative x over 8 minus 3 is less than negative 5. So again, I'm just going to go ahead and drop my line down as if this is where my equal sign is. Instead of the equal sign, though, we have a less than symbol. And I want to undo all of this over here. So I see a subtraction of 3, and then I see that x is being divided by 8, and that fraction is also negative. So let's take care of the subtraction of 3 first. We're going to add 3 to both sides. That's going to give me negative x over 8 is less than, that cancels out my 3's, is less than negative 5 plus 3 gives me negative 2. Okay? Let me actually move this over just a little bit, just so it's a little bit more together here. All right, so now in order to undo that division, I'm going to multiply by 8, but I'm also going to multiply by negative 8 because I want that to cancel out the negative and the 8 at the same time. So we're kind of taking care of both of those things all at once. So negative 8 over here on this side. So negative 8 and my negative and 8 both cancel out. So that's going to leave me with just x on this side. Negative 2 times negative 8, negative times negative is a positive. That's 16. And because that 8 is negative, we are going to flip the sign, and now it's going to be x is greater than 16. So this flip has to do only with the fact that that 8 was negative that I multiplied, not because the 2 was negative. Sometimes that gets a little bit confusing when we're first learning this new rule to solving. So it's not the number that you're multiplying that you're starting out with, it's the number that you're multiplying to cancel out that gets rid of anything that's with that variable. All right, so we found our solution of x is greater than 16. Let's go on to this last one. Now this one also contains a fraction. I wanted to make sure to include lots of fractions. Fractions are usually the thing that people ask about the most. So with this one, we have x minus 5 over 4 on this right-hand side. So 5 is greater than x minus 5 over 4. Whenever you have an addition or subtraction all in the numerator or all in the denominator, you're going to treat that as if it's in parentheses for the sake of how you're going to undo all of these operations to get the variable by itself. Meaning that normally we would undo any subtraction or addition first before we worry about division. However, because that subtraction is in those parentheses, we're going to undo that subtraction last and take care of this division of 4 first. All right, so we're going to multiply both sides by 4. 4 over here, and we can drop our line down through like that. That's going to cancel that out because this whole quantity, x minus 5, is what's being divided by 4. So we need to undo that division first before we work on that 5. So we get 20 over here. We're keeping that inequality symbol greater than x minus 5. All right, and now we can take care of that subtraction of 5 by adding 5 to both sides. That cancels it out here. 20 plus 5 is 25 is greater than x. Now in this example, our variable was over on the right-hand side of our inequality, and that's okay. This is a perfectly acceptable answer. Some of my students like to flip it around so that the variable is first. So if you do that, that's also fine. We can do x first, but you also have to flip that inequality as well, because the 25 needs to be on the bigger or the open end of that inequality symbol, and the x needs to be on the smaller or less than end of that symbol. So when we flip it, x is still here on that smaller end. X is smaller than or less than 25. And then if we read it this way, 25 is greater than x. So it still works either way. So both of those are good solutions for this one. All right, our last example, we've got 12 is less than or equal to 2 minus 2/3 x. Again, there's a fraction included in there for you just to give you plenty of opportunities to practice with fractions. When the fraction and a whole number that are being added or subtracted are separate like this, then we are going to undo any addition or subtraction first and then worry about this multiplication of 2/3, a multiplication of this fraction. Okay, so in this problem, we have 2 minus 2/3 x. So again, that fraction, I'm going to wait till the last step to take care of that. This 2 is a positive 2. Don't let this subtraction sign fool you. This subtraction sign goes with the fraction, not with the 2. So in order to undo this 2, we need to subtract 2 from both sides. So that's going to give us 10 is less than or equal to, that gets canceled out there. And then the negative travels along with the 2/3 x. All right, so now we've got one last step to do here. We could break this down into several steps. We could multiply both sides by 3 and then undo the negative 2. What I'm going to do is I'm going to take care of all of this by multiplying by the reciprocal. So if I multiply by negative 3 over 2, those negatives are going to cancel out, the 3's are going to cancel out, and the 2's are going to cancel out. So I've taken care of 3 things all with one step. We can't forget to go ahead and multiply this side by negative 3 over 2 as well. All right, so we know that this side, we've already canceled everything out, so we know we have x. And then on this side, I'm going to go ahead and put my 10 over 1. And I can see that when I multiply these two, the 2 and the 10 can do a little bit of cross-canceling. 2 can go into both. So 2 can go into 2 once. 2 can go into 10 5 times. So I wind up with negative 3 times 5. And all that's going to be over 1. So negative 3 times 5 is negative 15 over 1, or just negative 15. Now, I did just multiply by a negative fraction, so that means I need to flip my sign. So now we've got negative 15 is greater than or equal to x, or if we want to rewrite this and have the variable first, we can write x is less than or equal to negative 15. Thanks so much for watching my video on two-step inequalities. I hope it was helpful for you. In the description below, I do have a link to my pre-algebra series. I have a ton of videos going over a lot of different pre-algebra skills that you might see in a typical class. So give that a look, and please don't forget to like and subscribe. That really does help me out, and I'll see you next time.